In today's tutorial we will discuss the polymerization of this molecule. It's trioxane, 6-membered ring with 3 oxygens. It is the cyclic trimer of formaldehyde. Actually, it is a case of a cationic polymerization, a ring opening cationic polymerization. What do we need for this reaction? Well, we need the catalyst, and this catalyst is an acid, either a strong protic acid or a Lewis acid. Well, let's say we have catalytic amounts of H+. In equilibrium, the trioxane will be protonated. And this molecule, this reactive intermediate, again in equilibrium, for this ring opening can take place. Leading to this primary carbocation. However, this carbocation is mesomerically stabilized by this oxygen, and now this intermediate can react with a second molecule of trioxane. So let's call that A plus A. Then, of course, this carbon is the electrophilic center. And again, a ring opening will take place. Better drawn in the stabilized form. And if this carbocation reacts again with the next and the next, the chain will be grow, and at the end, well, somewhere it will be trapped by an hydroxyl, an ion. Overall, one equivalent of water is added to n times this trioxane. Finally, we achieve this polymer chain, and it is a very useful material. For instance, those clamps from our chemical labs are made of this material. It's the so-called polyoxymethylene, and it is abbreviated with POM. Thanks for listening.